Hello dear students, we will continue with the remaining topic of chapter 2. Let us turn to page 18 and try to solve this numerical. In order to solve such type of numerical, the formula which we have to know is mass by mass percentage of a solution. If we are asked to calculate mass by mass percentage, the formula will be mass of solute divided by mass of solution into 100. If we are asked to calculate mass by volume percentage of a solution, the formula will be mass of solute divided by volume of solution into 100. The difference here it is mass, so denominator is mass, and here it is volume, so denominator is volume. Let us try to solve this. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So from this two, which one will be using? This formula, because here it is given calculate the mass by mass percentage. So here in this type of question where solute, solvent, solution are mentioned, first thing that we have to know is we have to identify which is our solute and which one will be our solvent. So here we have 40 gram of common salt. Common salt means the salt which we use in our kitchen. In 320 gram of water. So water is always a solvent. That means our common salt will be our solute and our water will be our solvent. We also know that solute plus solvent will give us a solution. When we dissolve salt in water, what we will get? We will get salt solution. So here, when we mix 40 gram of common salt and 20 gram of water, we are going to get our solution. So let us try to calculate the mass by mass percentage. As discussed, we have to calculate here mass by mass percentage. So we have the formula mass of solute divided by mass of solution into 100. So firstly, we have to identify what is the mass of solute and what is the mass of solution. So here let us write down mass of solute. We now know that our solute is going to be our salt. So here it is given the mass of our common salt is 40 gram. And what is the mass of solvent? As of now, the mass of solution is not known. So what we will write? We will write the mass of solvent because this is our solute and this is our solvent. So mass of solvent is 320 gram. 320 gram. Now what we have to do is we have to get mass of solution. Mass of solute we already got. Mass of solution we have to search. Now what is mass of the solution? How is a solution formed? A solution is formed when solute is added in solvent. When solute is added in solvent, we get our solution. So in the same way here, what we will do, in order to find the mass of solution, you will add up mass of solute plus mass of solvent. What is the mass of solute? 40 gram. What is the mass of solvent? 320 gram. So what do you get? 40 plus 320, you will get 360 gram. I hope you know the addition. 320 plus 40. You are going to get 360. So now we already got our solute. We got our solution. What we have to do? We simply have to put up the values in the formula. So mass percentage of the solution. You can also write mass by mass percentage of the solution, mass percentage of the solution or mass of the solution. It's all same. So here once again the formula mass of solute divided by mass of solution into 100. Now here we already have the values. Mass of solute 40. Mass of solution we just calculated 360 into 100. Since you will not be using calculator, you have to do it manually. You can either cross the zeros in this format or you can either do in this format. It's all up to you. So 0 0 cancelled. 4 9s are 36. So now you have to do your division. You will always do your division on your rough, that is your right hand side, but I'll just do here so that it's visible. So here whatever is present on the numerator will go inside and whatever is present in the denominator will go down. So here 9 and 100. So we will take up first the two digits. So 9 ones are 9, 9 twos are 18, 2 is greater, so 9 ones are 9. 10 minus 9 is 1 again, 0 comes down, 9 ones are 9. Once again you get 1. So in order to make it divisible, we will put a point here. As soon as we put a point here, we get a 0. So again 9 ones are 9. So it will continue. So we can stop it here. So what will be our answer? Our answer will be 11.1, and since we are calculating the percentage, you have to put the percentage symbol. So this is your final answer. Let's see the next question, which is given on page 19, question number 3. It is same as the previous one, just the number and the solute has changed. Now here, let us see the question. To make a saturated solution, 36 gram of sodium chloride is dissolved in water, 100 gram of water. Here, water is present, so this is our solvent. So this will be our solute. At 293 Kelvin, find its concentration at this temperature. Now what we have to find out here? Concentration. Concentration mass by mass percentage, we will be using the same formula. If you check page 17, concentration of solution is amount of solute, amount of solution divided by amount of solution. Now here, whenever we are talking about finding or calculating concentration of solution, mass by mass percentage, we'll be using only one formula, that is mass or amount of solute divided by mass or amount of solution into 100, because we have to calculate in percentage. I have already done the solution for you, however I'll be explaining it. Now we know that this is our solute and this is our solvent, so we will write down mass of solute. You can write in bracket sodium chloride, or even if you don't write, it's fine, because we have already mentioned that it is the solute. So mass of solute will be 36 gram, mass of solvent 100 gram, mass of solution. Now as I told you, solution means solute and solvent will be added up. If you write here 36, 100, 136, it is the same. So 136, 136. Now we have to find out the concentration of solution. So we are going to use the same formula, because mass by mass percentage and concentration, they are the same. So mass of solute divided by mass of solution into 100. So here mass of solute is 36, mass of solution is 136 into 100. It comes from the formula. You can divide it with the help of multiplication table, or directly you can go for the division. So this division you please try to do. You will get your answer as 26.47. Now here some of you will get confused, because here solvent is mentioned as water, and the unit for water is always liter or milliliter. So here, but remember, whenever we are doing this solute solvent, we are going to mention our solvent water in gram. So it is only for this particular portion. Let us continue with separating components of a mixture. We will discuss this topic, which is on page 21. How can we separate mixture of two immiscible liquid? Immiscible means which do not mix, somewhat like oil and water. In a previous class, we have studied about two methods. One was evaporation, second was centrifugation. Now in this method we'll be trying to separate two immiscible liquid, basically oil, that will be our kerosene oil, and water by using a separating funnel. Now this is what a separating funnel looks like. It is basically made up of glass, transparent glass. So here what we are going to do is, you can also see here it is written stop cork. Now here this top cork, actually this can be rotated. So this is basically like the cover of a bottle, where if we tighten this, the water is not going to fall down, and if we want the water to fall down, we are going to loosen this up. So here firstly we are going to put here water. Right after we put some water, we will make sure that this is tightened up, nothing is falling down from here. First we will put water, secondly we will put some kerosene oil, and we will close this. We will allow this mixture to stand. That means we are not going to disturb it until and unless it forms two layers. Obviously it is very logically we know that water and oil, they do not mix with each other. So here we will just leave them undisturbed until and unless the water and the oil layer separates out in a proper manner. Now here it is not shown here, but here what we will do is we will place a beaker. You already know what a beaker is. So after we place a beaker, what we will do, we will slowly open this cork. So when we slowly open this, what will happen? This lower layer of water will start falling down, but we will make sure they are falling down slowly, because this layer we are not going to allow this to fall. We will only take out all the water. So as soon as all the water has fallen down, we will again close this. So what we have done here, we have separated out water, and in this funnel what is left? Only the oil is left. So this is what our motive was, to separate the two immiscible liquid. Now here kerosene being lighter forms the upper layer, and water is heavier, that is why it forms the lower layer. So in this way we can separate the oil and water very easily. Let us see two applications of the separating funnel method. The first one, as we have done, it is used for separating mixture of oil and water. The second one, it is used for the extraction of iron from its ore. Extraction of iron method is known as metallurgy, which you will be learning later. So now you just have to know that it is used for the extraction of iron from its ore. What is ore we'll also learn later, not now. So just remember two applications. Let us quickly see the next one, 2.3.4 on page 21. How can we separate mixture of salt and ammonium chloride? So in this process, we'll be using a method which is known as sublimation. Sublimation method. The first one was evaporation, second centrifugation, third separating funnel. Here the fourth one is sublimation method. Now what is sublimation method? It is a process in which a solid is converted directly to gas. And on cooling, gas can directly be converted to solid. That means vice versa. So here solid getting directly converted to gas. There is no liquid form. Solid getting converted directly to gas, or gas getting converted directly to solid, is known as sublimation. So this method will be used up in this process. Let us see what is done in this process. Here, mixture of ammonium chloride and salt will be taken in a china dish. Here the lower one, which looks like a plate, I have already shown you image of a glass which looks like a plate. So here this is known as china dish. So here mixture of ammonium chloride and salt will be taken. Then this china dish will be covered with an inverted glass funnel. This glass funnel looks like this. It is basically like this. It is used in this form only. It is used in this form. But now here what it will be? it will be inverted. That means it will be made ulta and kept here covering this. Also, a loose cotton plug will be put on top of the opening of the funnel to prevent vapors of ammonium chloride to escape from the funnel. Then the china dish will be heated on a low flame and the result will be observed. Now here, as it is heated slowly on a low flame, it will be observed that white fumes or white vapors of ammonium chloride comes out of the mixture. The fumes, the vapor which comes from here, comes in contact with the cold wall of the funnel and the vapor solidifies. That means the vapor which was coming from here comes in contact with the wall and then here solidifies and deposits here. So what was our motive? Our motive was to separate ammonium chloride and salt. So what happened here? All the ammonium chloride went up as vapors and deposited here. What is left here? The salt is left in the form of sand. So our motive is complete here. Why is that the vapors of ammonium chloride rised up? Why not salt? Because ammonium chloride is volatile. Volatile means which vaporizes easily. That is the only reason why vapors of ammonium chloride rised up and what is left behind? Salt is left behind.